Okay guys, so in this video we are going to talk about multiple market support. So let's get into it. What we're basically going to cover isn't necessarily as specific as multiple markets. It's more about talking around the problem we might have with configurations and multiple clients and multiple stakeholders and permutations. And we're also going to talk a little bit about how to solve this in the at least painful way that I know of. So, as I was saying, the number one problem you have when you're dealing with multiple markets is permutations. Now, just to explain this, so let's say for the sake of argument that you're not in a country where let's take a simple example. Let's say that you're in a country where you're always going to use the same language. That means that you have one permutation of all the text that needs to be in your application. But let's say that you wanted to support an international application where you have multiple languages. Well, then you're going to have one logic fork or one permutation of everything that has to do with text per language you actually support. Now, what happens there is that your testing and the odds of something going wrong, well, it increases exponentially over like I'm not saying, well, technically it is exponential, it's linear, like you're simply adding one more case. The problem is that it's very rarely as simple as that. There's many other sorts of issues that come with that. That doesn't have to necessarily have to do with markets, but it can basically have to do with a simple thing as, oh, you have this system that was built and then all of a sudden your customers come in and say, hey, you know what, we need you to support this as well, and then the next thing, and then the next thing, and you build all of these, the support for the different variations of how the system can behave depending on who is using it. So the way that we want to solve this is to figure out, ideally, a generic way of solving a problem. Because as I was saying in the first case, the best situation is if you only have one permutation, but that's simply not possible all the time. So what we can do is that we can at least we can write our code in a way that makes the code act in one single way, or that we have at least one implementation, and try to isolate the permutations into a specific place, like into the peripheral or the outskirts of the code. And then we can use our best friend dependency injection to actually take care of the rest. Now, let's have a look at how this works. So I have this little TypeScript application here, or like an Express server, and this is our Express server. So we have a endpoint here called translations that is going to get some translations, and we have a formatting endpoint, which I'm calling like the bad one, and then we have the really bad one, and then we have the one that is pretty decent, and then we have an endpoint that makes us money, which is great, right? Who doesn't want an endpoint that makes money? And then we have our library here, a bunch of services and some other good stuff. And then we have a bunch of configurations. So let's just walk through this. Let's start with the translations first and foremost. So the first thing that we need to think about is, how do we support something as simple as translations? Well, there are many ways, but I will show you the way that I believe is the best way, and then I will explain why this is the best way, if you ask me. And then we will look at these formatting situations here, and we will talk about how they are solving the problem in a very similar way, but why they're less ideal. So when we're dealing with multiple markets, we usually want a configuration system of some sort, because basically what we need to know is, okay, as an example, we look at this logic here. So we're going to get a bunch of translations that are going to be sent back when we request the translations. And we want to basically say that, okay, you can ask for you can set a locale and then return that specific the translations that exist for that specific locale, right? But you might also want to have something like a default locale. How do you know what the default locale is? Well, you need to start up the application in a state or with a set of configurations that explicitly says this is the default locale. Now, the way I highly suggest that you do this is by doing this. you declare a interface. So this is a loader that basically loads up a interface of iConfig. So when we're dealing with configurations, typing is a very nice thing because this is what you get. The reason why we want to keep this typed is because usually when you have code that deals with permutations and configurations and different markets and different clients and stuff of this nature, it's very easy for you to forget to change different parts of the code if you don't track where your configurations are actually being used. So let's say, for the sake of argument, that, I mean, this rarely happens if I'm honest, but let's say that what we wanted to remove a key here, or like something where you realize that, hey, you know what, this fraction digits configuration, it's not really needed anymore because we have just decided that we're always going to round our fractions down to 2 decimal spaces, as an example. If we could make that decision, we don't need this key anymore. And this is where a type system becomes really useful, because then I can simply remove my key here, and I will find all the time, thanks to the compiler, I will find all the places where I actually need to make that update. But this is just our generic interface. And this is one of those really useful cases for an interface. You just declare an interface, and then you might have several different implementations of that interface, but it's the same code outwards. And what becomes really powerful about this is that you just depend on this configuration from inside of your code. You don't have to have a bunch of if-else statements and stuff of that nature. We're going to look at that as well. But this is a really powerful pattern, because now I can say things like this. I can have, in this case, a Danish configuration. I can have a Finnish one, Norwegian, and Swedish. And I can just keep on adding as many interfaces as I want. And at runtime, I do a little check here for an environmental variable that expresses to my code which market I'm going to start this application as. So if I'm starting it in a Swedish market, then we know that, okay, the configuration that's going to be loaded is for Sweden, Finland, Norway, Denmark, etc., etc., right? And then we throw an error if for some reason we're trying to start the application for a market that we don't actually support. And then we simply just expose this generic piece of code. This is a lot cleaner than if, let's say, for the sake of argument, that we were to do something like adding a bunch of switch statements or if-else conditions inside of the code, because we could do that as well. We can look at our services here, and we have a money service and we have our translation service. Like, we could, inside of here, just go and do something like that. We could do this. This is why I call it get translations the bad way. We could create an environmental variable and just reference that here inside of our code and then switch on that. The problem with that is that when you do this, you're basically adding a bunch of boilerplate for something that isn't really needed, because what you want is to just know what the locale is supposed to be when you're fetching that locale. So doing it in this fashion as we do up here is a little bit cleaner. So because it's the same thing, we've instantiated a configuration that holds the same information as doing this. It's just that it's happening in one place, and then it's the same interface all over the place, instead of us repeating ourselves over and over and creating these switch statements on and checking on this environmental variable. We do that once instead of doing it all over the place. And then we can simply pass around the configuration like this. So we instantiate our translation service with the configuration, and here we have a default locale for just getting a translation, and there's a key for that. And I have this like this little silly function that I created. This is just me saving some time, so I don't have to create a database implementation of this. But here I have some basic translations. I have two functions that basically does the thing that I was saying. It just switch matches on the different locales and returns the correct translation. It's the same thing here. And this keeps it very simple for us. Like there are no environmental variables or anything like that. We're simply creating a configuration. Like, our code is just consuming a config, and the only time we do anything like impure with an environmental variable is when we're actually creating that configuration, that initial version of it. So this interface now is getting dependency injection. It's the same interface for the code, but the creation of the implementation of that interface is being injected at runtime. And that's extremely powerful. It's extremely useful for testing purposes here as an example. So because we are using a configuration, I can show you how this is like. It's the same thing here. Like we're just instantiating this translation service, and then we're grabbing the configuration, and we're instantiating the service with the config we're getting from this configuration file up here. But if we want to write some tests for this, as we're doing here, it's pretty straightforward because there are no environmental variables or anything like that. The way we don't have to like set an environmental variable or add something like that to our test. We simply have to create a mock configuration, instantiate our service with that mock configuration, and then run the test. This is a lot cleaner than if we have an environmental variable or something like that that we simply need to provide before the test runs. This becomes a much more isolated experience and much more clean, testable, call it whatever you want, right? And so that's one way of thinking about this, where you're basically saying, okay, I have a bunch of configuration values and I want to instantiate those in some fashion. I need to provide them through the code. I'm not saying that environmental variables are bad. They're really, really nice and useful, but you should isolate the usage of them to just an object that holds all of these configs, because otherwise they litter the code all over the place and it becomes really hard to track them all down. So apart from that, we can look at a few other use cases here. So let's say that we have a formatting endpoint here. Now, this is another way. Let's say that we accept the idea, okay, we have a configuration of some sort. We're using dependency injection, which is absolutely awesome. And now we're going to add some type of logic such as this. We're going to send a sum of some number here. And then we're going to format it, where we're going to basically use toFixed on it, which is just going to set the number of fixed, well, the fraction digits, or like the decimal spaces that our number is going to use. So this is one way of doing that. So we have a switch statement that checks the configuration for the market, and then it just switches on all of these different cases. And the default is that it throws an error, but it might be a different default. We could configure that as well. Why is this bad? Well, I'm glad that you asked. Well, in my humble opinion, the reason why this is bad is because basically what we're doing is that we're not actually expressing the thing that we want. Because when we look at this code here, we're basically saying that, okay, because we're in the Danish or the Norwegian or the Swedish market, we want the fixed number to be 2. But the problem is that there's no real correlation between these two things. This isn't really explicit, it's just inferred. This is just logic that we've added. We could have just done something much simpler than saying that, okay, well, we write this code or a switch statement here and just checks that, okay, what should the number be if it's in Denmark, Norway, or Sweden? Well, it's going to be 2. So why are we doing it this way? Why not just add that value to the actual configuration? That removes the whole switch statement. This entire check for all of these cases becomes completely pointless because the value is already created. This is basically just a very weird way to do dependency injection, if that makes sense. You're achieving the same results. It's just that one result is created in one single place, which is in the configuration creation phase. This is actually being done, like this is being evaluated every single time we call this endpoint, when it doesn't have to. This is logic that we need to run every single time instead of just doing it once. And then we have the really bad implementation, which is kind of touching on the thing I was saying earlier, where now we're not even using the configuration. Here we're actually doing something like process.end.market, and then we're doing the same thing. Once again, if you do it this way, you're basically just doing the same. Like you're simply doing extra work. You could just do this once and then reference that value from within the code, like after the startup process is done, and never have to run this code more. Like you don't have to repeat yourself and you don't have to do extra work. So this is the way that you should start thinking about it. The way that I feel is the best way to describe it is to say template coding. Think of your code as a template. Basically, like all of this code here, it's like rendering out an HTML template, or if you're one of the cool kids using server-side rendering for React, right? You create a template that holds some code or some markup or something like that, call it whatever you want, right? And then you simply have a dynamic value that you want to inject into that piece of logic, and that's exactly what this is. This thing here there are no permutations here. You don't have to like do a bunch of tests for the different cases here, or run different multiple tests to verify that, oh, for Denmark it's going to behave the right way, the Norway and Sweden and so forth is going to do this, and then the default case is going to do that, because there's only one path. The only path that can take that this can take is that the to fixed is going to reference the fraction digits set in the configuration. So it reduces the overall testing that is required, and I think that it becomes much cleaner. Lastly, we need to think about something that is different as well, which is that so far we've only talked about value injection, which is something that is very useful when we know what the value is going to be beforehand. There is another case, which is logic. Logic is different because you might have the case that, all right, so if you're running in one market, you should do one thing, and if you're running in another market, you should be doing something else, depending on the situation. And this is the case for this money endpoint that I have here for the money service and making money. There are different ways to do that in this application. So let's have a look at that. So here is my money service, and the same approach is pretty much taken here. So we have this money service that we the interface that we are exposing, and basically what we're saying here is that we're doing the same thing as we were doing with the configuration. It's just that we're instantiating different services depending on the runtime configuration. So we take in the configuration and then we switch and we say that, okay, if the market is Sweden, well, instantiate the Swedish money service, because in the Swedish market we have one way of making money, and in all the other cases we have the same way of making money. But it's very easy for us to simply add another case here and say that, oh, we're going to go to Belgium, or we're going to go to America, North America, or something like that, and then we can add another case with another service that knows how to actually perform that operation while still complying to the same interface. This function here is what we call a factory function, and it's the basics of dependency injection. So if I have a look at money service here, that's all it is. It's just an interface that says that, okay, there should be, on my money making service, there should be a make money function that complies to this interface or to this signature. And so in my general money making service, I'm just creating an instance or a class that has the knowledge of how to do this. And in Sweden, I have a similar thing where this is a completely different service. It can look at, like, as you can see here, this is taking in a config and it's doing some other logic. It's doing its own thing, but it's still abiding by the same interface. And that's why this becomes generic, because from the perspective of this application here, like the money making service, it can be either the Swedish money service or the general money service. It doesn't really matter, because the behavior, the call signature, and all the things around it is the same. The underlying implementation might be different, but we don't really care about that as the caller, as long as because we have this awesome, nice generic interface. So this is a way to deal with, to use dependency injection to actually instantiate pieces of logic. You can take this one further. You don't have to match on something that you know at the boot time or at the startup time. We could have also had something very similar to this, some type of factory function that took in, let's say that we sent in a parameter or something like that from the client when they actually connect to this API. Then we could match on that instead and say that, oh, okay, if they send a variable or a parameter that is foo, then we instantiate that logic, or we're going to execute that logic. If it's bar, we execute that logic. It becomes the same thing. So what I want you to take away from this is that if you're dealing with a highly configurable system, usually something like a multi-market system, or where you have one system that multiple different customers are using and they have their own requirements on how it's going to behave in different circumstances, going with this configuration-based system is a very clean approach to doing that. And I highly encourage you to just declare an interface for what your config is going to look like, and then instantiate that configuration as quickly as possible, and then just reference the config without necessarily using a bunch of environmental variables or if-else's all over the place. And then when you have that config, Try to avoid falling back into that trap of just switching or doing if-elses and stuff like that. Try to think about your code as a template where you reference, like you create a value that represents all the possible permutations that you can have of something, if it's a value, and if it's like a piece of logic, do something like this. Create a generic service or some generic interface for that piece of logic that represents that, and then use dependency injection like this to simply specify that, oh, it's going to be that piece of logic or that piece of logic that actually executes under the hood. This keeps the code extremely easy to maintain, even though ideally we wished that we didn't have to do this sort of thing. But it's very useful to know how to do this, because I can promise you that you're very unlikely to go your entire career without having to create a switch statement that simply says, oh, if it's this case, do that. If it's that case, do that. Even though it's pretty much the same logic. Have a great day.